Hi everyone. We reviewed today conic sections, so I decided to do a video about conic sections. It's not finished work, it's still in progress, so there might be a couple of mistakes throughout the video. Please check them out, check it with your notes, and just take it as a helpful hand for your review, for your studying for this weekend, okay? It's nothing more than that. So in order to find out what type of conic section you have, you first have to look at the general formula. If you have the standard, well, you already know the parts of the standard and how it's written. But in the case of the general, you have to look at A and C, namely the two terms that are squared. So in this first case, if the factor of the x squared term, namely A, is equal to the factor of the y squared term, namely c, then this is a circle. So just by completing the square for both terms, you will find out the standard equation going from the general to the standard. Now, the parabola is a different story. In the case of the parabola, it's normally written like this. If you look at it at first glance, you'll find out that there's only one term that has a square term, okay? It can either be x squared or y squared, but there won't be any other x or y square. Now, it would seem like it's not there, but in reality it is, okay? It's just that when you have something multiplied by 0, it's equal to 0, therefore you normally don't write it. But it's still there, okay? So we can look at it more developed in this way, okay? Basically what it's telling you then is that if you have one of the terms that's squared different than 0 and the other term is equal to 0, so for example, different to 0, A, equal to 0, C, then you have a parabola. Or the other thing that can happen is that A is equal to 0 and C is different than 0. Therefore, you're going to get a parabola. And the difference between the other conic sections is that here, instead of completing the square for both terms x and y, here you're only going to complete the square for the term that you found that here was to the square. The rest, remember, you send to the other side, to the equal sign, and you will have to factor out a term that will make the variable that was not elevated to the square equal to 1, and outside you're going to get this factor, and that factor later on will remember that is equal to 4c. Okay, so once again we look at A and C, and in this case for the ellipse, they're both going to be positive. Mainly, in other words, they're going to be greater than 0, but they're going to be different. So when I transform this into the standard form by completing the square, then what I'm going to get is this equation or this equation. And we're going to talk about the difference between these two, because as you can see, B is in this here and A is here, and we're going to talk about the differences in a minute, okay? But just identify it first. Okay, now, last one. If A and C, once again, are different, okay, but in this case, A is greater than 0 and C is smaller than 0, namely one is positive and one is negative, then you get a hyperbola. It doesn't matter, as you can see here, A can be the big one, and the positive one or the negative one, as long as the other one is a contrary, okay? And once again, you're going to transform into the standard form by completing the square, in this case of both x and y terms, and you're going to get this. Now this is going to give you both a horizontal or a vertical hyperbola. We're going to see how in a minute. Alright, so for the circle, what we're going to have is this equation. This equation has x minus h and y minus k. Equal to a radius, and this radius is to the square. So the h and k part are going to give you the center of the circle. So in this case, for example, we have minus 3 minus 5 equals 6 squared. So the minus 3 is going to give you the x-coordinate for the circle, and the minus 5. Remember that we changed the sign of this, okay? So it becomes this. It's important to understand the changing of the sign, because when you have something different, like for example this, then if you have, for example, plus 3 instead of minus 3, then what you get is the center will be in minus 3, because in reality, remember that plus 3 is a subtraction of a negative number hidden. So you would have minus 3. So this minus 3 goes here, okay? So your center will be now in minus 3 comma comma 5, positive 5. So this will be, the radius, as you can see, is still 6, okay? So it will be just like this one, but in this case, it's transferred because your center is now different, okay? Once I've identified it's a parabola, I have to identify if it's a vertical or a horizontal parabola. To do so, I have to look at the term that's squared. If the x is a term that's squared, then it's going to be vertical. If the y is a term that's squared, then it's going to be horizontal. But as you can see, it also can open up or down, right or left. The way that I know if it's going to be to do one or the other is if I look at the term that's multiplying the term that is not elevated to the square. And this, for this side, or for this equation where it's vertical, I'm talking about y. And for the horizontal, x is a term that's not elevated to the square. Okay? So the term that multiplies it is 4c. If it's positive for a vertical, it will open upward. If it's negative, it will open downward. In the case of the horizontal, if it's positive, it will open to the right. And if it's negative, it's going to open to the left. Something else that's very important to take into account is that a parabola does not have a center. It has a vertex. So the terms that we're normally used to telling us a center, namely h and k, will not give us a center, but will give us the vertex of the parabola. So now that we know these, identify if it's a parabola, if it opens up or down, left or right, now we have to find the other main parts. First of all, we're going to take the vertex, which we already know comes from the equation, and it's the terms h and k. Just take into account that no matter what, x will always be accompanied by h, and y will always be accompanied by k. It doesn't matter which of them is elevated to the square. If this were the other way around, namely the y were the term that's not elevated to the square, and the x were the term elevated to the square, the x would still be accompanied by h, and the y will still be accompanied by the k. So it will be like the other way around, but this one not squared, and this one squared. Okay, so just take that into account. Now, once I know the vertex, I need to find the other points. But first, let us understand how you build a parabola. A parabola is built or defined in the following way. I have a directrix. It's this line. I have a focal point. Okay? The distance between the directrix and the focal point, half the way, I will always find the vertex. Okay. So now that I know that, if I draw a line that goes from the directrix and is perpendicular to that directrix to a point, okay, the distance of this line from the directrix to the point and the distance from the point in the graph to the focal point will always be the same. So, why is this important? Well, it will help us define other things in the future. But something important to note here is that while other conic sections have A and B. There is no A and B here. So I need to find C, which will give me the distance from the vertex to the focal point. And as you can see, and we're going to look at it in a bit, it will also give me the distance from the vertex to the directrix. But where do I get C from? Well, it depends. If you have the equation, you know that 4C will multiply a term that is not elevated to the square. So, what do? You equal 4C to that term. So, 4C is equal to whatever you have here. You solve for C, namely divide whatever you have there by 4, and you will get the value of C. Once you do so, you will get the two terms. So, the distance between vertex and focal point to C and the distance from vertex to directrix is also C. All you have to do is take into account the direction in which the parabola opens and if it's a vertical or horizontal parabola. So in this case, you know that it opens to the right, so the focal point has to be to the right of the vertex at a distance C, and the directrix will be to the left at a distance C. Okay? It's that simple. That is if you have this equation. So what do I do if I have it the other way around? If I have the graph and want to go to the equation? Well, it's straightforward. The h and k terms, well, you're going to find from the vertex, the coordinates of the vertex. But 4c is actually the distance between 2 points that are determined by a line that crosses the focal point. So if I measure this distance from here to here, it will be the equivalent of 4c. So once again, that measure will go here. And if I need to know the specifics of how much 4c is, I can solve for c here, depending on the distance. The other thing I can do is measure the distance from the vertex to the focal point or the vertex to the directrix and multiply it by 4. It's your choice. So now we're going to go into the ellipse. Now, the ellipse will always have the shape, like a oval shape, okay? And if the long end is horizontal, then A, which is the biggest term, like for example here, will be under the x square, okay? So, if the longest term is under x squared, it's horizontal. If the big term is under the y square, then it's going to become vertical. Take into account that in this case, a will always be the big term, okay? So, no matter if they're the same equation, just they have the same center, just different orientation. So in this case, if 9 is on the left, then a is a left term. If 9 is on the right, then a is on the right term. Okay? So that's very important to understand, because later on when we find the rest of the terms, we have to know which is a and which is b. Alright, so now we're going to go into the the ellipse. The main parts of the ellipse are its center, vertex, and covertex. Okay? The distance from the covertex to the center will always be smaller than that of the distance between the vertex and the center. Okay? So if we make a little triangle, we're going to find A is always the longest term. Okay? So that's why in an ellipse, when A is under the x square, it becomes horizontal. And when it's under the y square, it becomes vertical. Okay. So, we can find A by looking at the graph, in two places. One is the distance between the covertex, the point B, and the focus. Okay, so focus in B is equal to A, but also the distance from the center to the vertex is also A. So you'll always, no matter if it's an ellipse or a hyperbola, you're always going to find that A runs along the main axis, the major axis, sorry, okay? Just be careful, because in this case, C also runs through the major axis, okay? But just take it into account. So, now B will always go through the minor axis, okay? So that might be a better reference point for you. Anyway, you can find B here, okay? And B obviously will come for the equation. So, you found the center, you found the distance from the center to the vertex, which is A, so you can find the vertex. You also have the distance, which is the distance B, which is the distance from the center to the covertex, okay? So, all this data you can find just by looking at the equation. The only thing you're missing is C, okay? So C, where do you find C from? Well, if you take the Pythagoras theorem, you're going to find that C is equal to A squared minus B squared, okay? So the square root of that will give you C. So with that, you can find all the distances, points, and whatnot that you need for this conic section or ellipse. Now let's look into a vertical. It's the same thing. As you can see, the distances are the same, okay? It's A is still the distance from the focal point to the covertex. C is still the distance from the center to the focal point. And B is still the distance from the center to the covertex, okay? And as you can see, A is still the hypotenuse of this triangle, okay? And A will still be the distance from the center to the vertex, and will still run along the major axis, and the minor axis will be the distance, marked by B, okay? In this case, 2B if you go from covertex to covertex. Okay, so now that you have that, what's the difference then? Well, if you observe the equation, now the long end, namely A, is under y squared. That's the difference, okay? So it's all you have to look for. The rest doesn't change one bit, okay? Just take into account that the way C and B are arranged in your triangle are flipped over, but that's the same thing, okay? Hyperbolas are the conic section with the most parts, so we're going to go step by step. First, we're going to identify the center, okay? Once I know it's a horizontal, and the reason I know it's a horizontal is because x is a term that goes before the minus, and y is a term that goes after the minus. So, I know it's horizontal. I now then look for the h and k terms that will give me the coordinates of the center. Once I find those, the next most important step is to identify which is a squared and which is b squared. Unlike the ellipse, where a will always be the biggest one, here it doesn't matter. What it matters is which goes first and which goes second. So, the a will always go before the minus sign, and b will always go after the minus sign in hyperbolas. So once I've identified that, I have to identify which is the distance or the amount given for A and for B. So A will always be the distance from the center to the vertex. Why do I know that? Because just like in an ellipse, A will run along the major axis, okay? And B will be part of the minor axis. So that means it will run from the center to the covertex, which is what we can find here. The center to point B, which is marking the covertex. Now, how do I find C? Well, C is quite simple. This is normal, let's say, normal Pythagoras triangle. So C comes out from a very well-known equation, which is C equals a square, square root of a square plus b square. Okay, so now I have a, b, and c. I have all the terms I need to find the points that are important in a parabola. So the distance, once again, from center to vertex equals a. From center to covertex equals b. And from center to to focal point is equal to c. This is logical because the hypotenuse is the largest term of this triangle. So therefore, the distance from the center to the focal point will be bigger than that of the distance from the center to the vertex. Okay, that's quite logical if you think about it for a minute. Okay, so why is it important to find all these points? Because now that I have these 4 points, both covertexes and both vertices, I can now make my square, or my rectangle in this case. Okay, and now that I have my rectangle, this will allow me to find the points through which my asymptotes will cross, and this will then allow me, once that I have my asymptotes and my vertex, to trace the hyperbola. Okay, we're going to find out how to find the exact equation for the asymptotes in a minute. I just want to compare them. First, I want to compare, the hyperbola, the horizontal, with the vertical. So let's go see the vertical. Now, the vertical hyperbola has the exact same parts. As you can see, the order of a and b was not altered. A goes first, then the subtraction, then b square. But in this case, y square goes first, and then x square. Okay? Now, we said that it's important to understand that a square goes from the center through or to the vertex. So this is my major axis. Even if it's smaller than this other one, this is still my major axis. Okay? And the distance, once again, from the center to the vertex is still a. The distance from the center to the covertex is still b. And the distance of c is still defined by the Pythagoras theorem. So I have b and a, and so I have c is equal to square root of a plus b, of a squared plus b squared, Okay? So as you can see, none of these facts or terms changed. What changed is where we put a and where we put b. So it's important to understand that a goes from the center to the vertex. It doesn't matter if it's vertical or horizontal, and that b will always be the axis that's perpendicular to that major axis. Okay, so once you understand that, understanding where a and b is should be a cinch. So now we're going to go on to find the equations for this axis. So we have to go back to Math 2, first of all, and remember that any straight line is defined by the equation, the standard equation, y equals mx plus b, where m is the slope. So how do I find a slope? Okay, so I determine where I'm going from what point to what point. So to make things easier, I'm going to say I go from the center to the next point to the right, which in this case would be here. So, by definition, the slope is how much I travel in y over how much I travel in x. So for this particular slope, I travel this distance y over this distance in x. Okay, so both are positive. I'm going to get a positive slope. And this can be easily proved because my line goes upward. Okay? Now, since my line goes downward for this one, I know that it's going to be a negative slope. How do I obtain a negative slope? Well, the principle is still the same. I have to see or find out how much I travel in y over how much I travel in x. As you can see, the distance x I'm traveling for both is the same. Okay? Nevertheless, the distance I'm traveling for this one in y, instead of being positive, is now negative. So I have a negative distance in y over a positive distance in x. So that's what's going to make the difference, okay? As you can see, the amounts are going to be the same. This d and this d, the absolute values, will be the same as this d with this d and this d with this d. But you have to be careful with the sign, okay? That's going to make all the difference. So now what do I do? Now that I found my slopes, well, all I have to do is substitute. But I'm still missing things because I don't know how much y or x is worth, and I don't know how much b is worth. But I do have a point with x and y coordinates, which is my point, my center. As you can see, asymptotes will always cross the center of my hyperbola. So if I know the coordinates of this point, which are, by the way, h and k, I can substitute that. So y is k and x is h. So now I have all this information. I can solve for b. So if I solve for b, I'm going to get this. Once I solve for b, I once again go back to my original equation and put b. Please do not get confused with this b and the b from the equation of the hyperbola. They're not the same b, okay? So, once I do that, I will obtain y equals my slope, whichever my slope is, times x plus the b I just found. And that will give me the equation of the asymptote. Remember, all hyperbolas have two asymptotes. Now, what's going to change between this one, which is the horizontal, and the vertical? Let's see. Let's now take a look at the subtle differences there are between a vertical and a horizontal hyperbola and their asymptotes. So, if we look here, the distance I travel in y is equal to b. Okay? So basically what I'm saying is that from the center to here, to this point, we're going up, I'm traveling b. And when I'm going to the right, I'm traveling a. Okay? So now let's compare that to a vertical hyperbola. In a vertical hyperbola, what I'm going to get is that the distance I'm traveling in y, okay, since now the major axis is is vertical, then I'm now traveling a as a distance of y and b as a distance of dx. So the procedure over here, same thing. The way you find the slopes, same thing. It's just a matter of paying attention to, once again, which is a and which is b. Okay, so let's put an example to all this to make this a bit more understandable. Here I have x minus 1 square minus y plus 2 square over 9. And sorry, over here, over 16. So, from this, I can find a, which will be equal to 4, and b equal to 3. And I can also find the center, which I know this will be h, therefore 1, and this will be k, therefore minus 2. So now I have a, b, and the center, okay? So now I can find all the other data all the other points. So from the center to the first covertex, all I have to do is, I'm still in x1, but it's minus 2 plus b because I go up b. So b is 3, leaving me at 1 comma minus 1. On the other side, instead of plus b, it's minus b, so it's minus 3, and so I'm now in 1 comma minus 5. Okay. Now for the vertex, I will be at a distance of a, because I know that how do I know that this is a? Because since it is a horizontal hyperbola, I know that this is a major axis and that a runs along the major axis. So I have 1, what I won't change is the y, so I'm in minus 2, but 1 plus a, because I'm going to the right, so 1 plus 4 equals 5, so this point will be in 5 comma minus 2. On the other side, instead of having 1 plus a, it's going to be 1 minus a, still on minus 2 because I'm not going up or down, so I'm still on the same y. 1 minus 4 minus 3 comma 2. So those are my points for all, so my vertices, co-vertices, and center. So now we're going to find C. How do I find C? Well, I have A, I have B. If I make my regular old 90-degree angles triangle, I know that C is a hypotenuse. So by theorem of Pythagoras, I know that C is equal to a squared, square root of a squared plus b squared. So C is equal to 16 plus 9, which is the sum 25. So C is the square root of 25, which is equal to 5. So now I know that. So the distance from the center to the focal point is C. So I'm in the center at x comma 1. And since I'm going in this case to the left, it's minus c, therefore minus 5. I'm still on 2. I don't move from the center y, which is also minus 2. So 1 minus 5 minus 4 comma minus 2. For the other side, instead of being minus c, it's now plus c. So still on the minus 2 because I'm not going up or down, but it's plus c, so 1 plus 5, 6, so it's 6 comma minus 2. So now the next part seems a bit more tricky, which is the asymptotes, but in reality we now know that it's very simple. First I have to find the slope for each of my asymptotes. Just by looking at them, I know that my this asymptote will be positive because it's going up, and this asymptote will be negative because it's going down. Let's find the first asymptote, the blue asymptote first. Okay, so if I start at the center and go to this point, I am actually going down y, and this y is actually b. Okay, so I'm traveling a distance of minus b, and I know that b is equal to 3, so I'm minus 3 down. Then I'm traveling to the right this distance, which is actually a. So I'm traveling for positive. So now I have my slope, which is actually minus 3/4. So minus 3/4, if I substitute it here in my equation, I have y equals minus 3/4 x plus b, but I don't know b. I do have, nevertheless, a point y and x, a point that goes along this asymptote, and that and I know the coordinates for, which is a center, and I know that the y coordinate for the center is k and the x coordinate is h. Therefore I substitute it and find this. Solve for b and get this. So this will be b, only b, for my blue asymptote. This b I have to put back in the original one with the slope I found, and I'm going to get the equation of the asymptote. Let's do the same procedure now for the second asymptote. This one's going upwards, so I know this one has to be positive. How much positive? Well, from here to here, I'm traveling up b. So in y, I'm traveling b, which is 3 positive. And I'm traveling to the right, a. I'm also traveling on an x positive. Therefore, it's 4. Okay, because I know that a is 4, but since it's positive, it's 3/4. That's my slope. Once again, I'm trying to find b, so I need a coordinate for one of the points, which is in this case the center. So once again, k and h, minus 2, comma, and 1. I solve for b and get this. Okay, then this b needs to be substituted up here with the slope that I found. So this is going to be my result. This is my asymptote. It goes downwards, and this is my asymptote that goes upwards. Now I have my covertexes, my vertices, focus points, and asymptotes. All that's missing is the actual graph. So I know it touches the vertex, and I know it tends to the asymptote, but never touches it. So now I can trace a route that turns here and goes towards the asymptotes, but never touches them. And therefore, I now have my graph. Okay, last topic, eccentricity. For us, eccentricity is the relationship or the ratio between the distance and of the directrix to a point in the graph and the distance between that point in the graph and the focal point. Since there is no focal point in the circle, then we define it as 0. The distance, by definition, between the directrix and a point in a graph and that point in a graph and the focal point in a parabola is the same. Therefore, I'm going to have whatever the amount over the same amount, so the ratio is always going to be equal to 1. Now, where it changes a bit is for ellipse and hyperbola. Okay, the eccentricity will be equal to c over a, but in both. But c for ellipse is square root of a squared minus b squared, while in the hyperbola it's square root of a squared plus b squared. So be careful. It's a very simple thing to remember. We already actually know how much c is. It's just that you mind your signs, okay? And obviously this will all be divided by a. So in the case of the ellipse, your results will always be in a number between 0 and 1. It will never be 1, because if it's 1, then it's a parabola, okay? So be careful. Between 0 and 1. And in the case of the hyperbola, it will always be greater than 1. Once again, it can't be 1, because if it were 1, it would be a parabola.